Okay, our second video for section 1.6, we're going to talk about that step function that we talked about at the very end of that last one, give you an explanation of what it means. So that's the only objective we have for this section, is to understand and evaluate step functions. You may recall that this is what the step function looked like. We're going to be returning that graph in a second, but first I want to kind of get into what it means to be the step function. Step function requires a little bit more description. Yeah, I know, I just said that. It's that double bracket, and what it means is it kicks out the greatest integer that is less than or equal to x. So if I take the greatest integer less than or equal to 4.3, that would kick out a 4. Greatest integer less than 4.3 is 4. So you might want to think about it as a rounding down, except it's not really rounding, because even if I had the greatest integer of 4.9, that's still equal to 4. Okay, so it's not technically rounding down, but you might want to think about it as bumping down. So the greatest integer of 4.3 is 4. How about those three? I want you to take a look at those. Probably pause the video right now. Come to your own conclusion about what those three values are. Alright, so here we go. 2.9, the greatest integer of 2.9 is 2. Okay. Greatest integer for 8 is just 8. Nothing to do on that one. And I'm willing to bet that this last one you got wrong, because you probably said negative 2.6. But you have to remember, when you get into negatives, negative 3 is less than negative 2.6. Negative 2 is greater than. Okay, so we got to keep the same rules even when we go to the negative side. So, to explain this a little more, I want to take a look at the graph that we were just looking at before, and it's actually a blown up version of it, to kind of understand what we're doing here. Let's go with a nice shade of green. Alright, so as we look through this, if I consider the point right there, maybe that point is, I don't know, 0.6. Okay? So what you would do graphically is you would round down. If you round down from 0.6, you stay at 0. So that means everything between the actual 0 all the way up to this next point rounds down to 0. But then the second that I hit 1, it bumps up to 1. Then when it's at 1.1, it rounds down to 1. 1.2 rounds down to 1, and so on. Okay? And then as soon as it hits 2, it bumps up to the next one. Because remember, it was the greatest integer less than or equal. So don't forget that or equal, because that's where we get these closed in circles and empty circles. Okay? So this is between between 0 and 1 point, let's start that over. Between 0 and 0.99999 whatever stays at 0. As soon as it hits 1, it bumps up to here. Okay? Hopefully that makes sense. Now let's take a look at the negative values. At this value of x right here, that would be maybe negative 0.6 again. Okay? The greatest integer less then a negative 0.6 is a negative 1. So any values of x in this region bump down to here. Hopefully that makes sense. If it doesn't, make sure that we get this clarified tomorrow in class. Alright, let's continue on. In the previous couple of slides, we went through the example, the greatest integer up to 4.3 was equal to 4. Okay, and then we did some numeric examples. Well, what I want to do in this one is actually give you a formula and have you figure out what value gets kicked out after you've done the complete formula. So, what I'm asking for you to calculate is what is f of 2, f of 6, f of 3.2, f of negative 2.1, f of negative 5.6. I want you to pause the video and give those few a try and see how you did after you're done. Pause it now. Alright, so we're going to take this one at a time, starting with f of 2. Okay, so what I'm going to do is plug 2 in for x, and I'm just going to go through this in a normal algebraic process. So when I plug 2 in, inside the parentheses is 2 minus 2, which is 0. I'm going to sneeze. I held off, and I held off just for you, and I hope you know how painful that is to do. So, inside the bracket you have 0, 2 times 0 is 0, plus 1 is 1. So your answer for f of 2 is 1. Next, f of 6. Alright, so when I plug 6 in, I get 4 inside that bracket. I don't have to round that at all. It already is an integer. So 2 times 4 is 8, plus 1 is 9. Next, 3.2. Okay, so now we're going to get to some of the rounding issues. Plug 3.2 in. 3.2 minus 2 is 1.2. What do I get when I take the greatest integer up to 1.2? I get 1. 2 times 1 is 2, plus 1 is 3. Hopefully you're doing well on this so far. Now it gets even hairier. Now we're going into some negatives. So I plug negative 2.1 in. Negative 2.1 minus 2 is negative 4.1. Okay? The greatest integer less than or equal to negative 4.1 is negative 5. So that becomes 2 times negative 5 plus 1, and that is negative 9. Last one. F of negative 5.6. Plug it in. Negative 5.6 minus 2 is negative 7.6. Bump that down to negative 8, and you get negative 15 for your answer. That is it as far as step functions go. We may need to talk a little bit tomorrow about how to graph some step functions, but that's it for right now. Ta-ta.